Okay, ladies and gentlemen, boys and girls, we are here for lesson 4 of our second science unit. So, before we get started too much here, I'm going to post this video link in, um, provided I remember, in the Google Classroom post. Um, it's a video of a crash test, right, from old cars and new cars. And I want you to think about when you see them, what's the difference between the old car and the new car? Which one do you think is safer? Okay? So, I want you to, before we start, watch this video. Okay? The crash test video. Once you've watched it, you can come back to this one, okay? So, pause here and watch the video. Okay, assuming that you have watched that, when you look at the new car versus the old car, we can easily see that the old car is way more unsafe. The whole front collapses, doesn't have seat belts, no airbags, nothing like this. Okay? What we're going to talk about today is safety of structures, right? If we didn't think about safety when we built something, it could be very bad, right? Like let's say the school, if we were all in the school and nobody thought about making the structure of the school safe, it could fall apart and the roof would fall on our heads, right? So it's important that structures are made safe. And today what we're going to talk about is the importance of safety, and we're going to talk a little bit about how um, different environments require different things for safety. Okay? So, first I want to talk about something called the margin of safety. Margin of safety, which is the limit within which a structure's safety performance is considered acceptable. All right? So we can't make something perfectly safe. It is impossible. Okay? But we can set a standard. What this means is, for example, a desk needs to be able to hold, say, 250 pounds of weight. No, probably more than that. Let's say 350 pounds of weight. All right? Because odds are nobody's going to put 350 pounds on a school desk. Probably not. So we make sure that if somebody sits on the desk, because people come and sit on desks all the time, or somebody puts something heavy on the desk, it's not going to break. All right? We're making sure the desk is safe to hold a large weight. All right? That is our safety margin. In this case, it's 350-pound worth of strength. Okay? The margin of safety also might be based on flexibility. It has to have a certain level of flexibility in order to be considered safe, right? Remember last time we talked about very tall buildings which sway in the wind like trees. Hang on.
Miss, thanks. You have a phone call.
Okay, somebody has a phone call. We have a very large margin of safety. No. Hang on, let me back that up. That announcement threw me off. Okay, so margin of safety, we have very large buildings. They sway back and forth in the wind. All right? They have a margin of safety that determines how flexible they need to be. They can't be 100% flexible. They can't be totally able to bend like a rubber band because at that point the building's not strong enough to actually stand, right? So there's a bit of a trade-off here. So the margin is based on, well, how much should we allow it to sway back and forth, right? That's what the margin of safety is. It could be either a strength or it could be a flexibility. It could be a temperature it has to withstand, things like this, right? And the margins of safety for structures often are set by law, right? Cars is a big one. Cars have to reach certain safety standards, otherwise, you can't sell them legally. Okay, so like I was just mentioning, your safety considerations can change depending on the environment. So here we have a snowmobile, which we've all seen before, probably. And here we have what's called a dune buggy, which is a desert car. All right. So, what safety considerations might be different for these two things? Well, this one needs to be able to withstand cold weather, right? Without failing. And this one, you see how it's open like this? Well, that's so the people inside don't overheat because deserts are very hot, right? So we have the open cage here. If you tried to have, if you tried to take this into the snow, A, the wheels would probably get stuck, and B, the people inside would be very, very cold. I suppose you could wear a coat, but even still, right? So this one needs to be designed so it can withstand heat, and this one needs to withstand cold. This one also needs to be able to withstand water, right? Snow is water. So you get a whole bunch of water on this. You don't want it to get damaged by water. Here, it actually has to be able to survive in very dry conditions. Not a lot of water. I know there's an ocean here, but ignore that for a moment. Not a lot of water in the desert. Okay? So depending on what the structure is, it's going to need different safety considerations depending on where it's supposed to be used. All right, yes, this. This is called the Leaning Tower of Pisa if you have not seen it before. Believe, believe it or not, it used to go straight up in the air. This building is actually leaning, right? Because this side of it has sunk into the ground. It used to be flat flush with the ground. But because when they built it, they didn't look at the soil underneath. The soil on this side was kind of soft. So the weight of the building pushed in, and now half of it is sunk into the ground, right? So this is why we need to consider the soil if it's a building on which a structure is built. We need to consider this. Otherwise, you get something like this. Now, for in a more serious situation, like this has been reinforced since, so it's not dangerous. But in some situations, it could become dangerous. If you don't notice, you don't reinforce, the whole building could sink into the ground over time, and then the foundation cracks and the building becomes unstable. All right? So we have to look at the soil, make sure we're building a building on an appropriate bed of soil. Okay, that's next time's. All right. So your task for today is to do this sheet called Building Safe Structures in All Environments. All right, the first question asks, when you're designing and constructing a structure, the manufacturer, so the builders, guess how strong and flexible a structure has to be. Then they make it even stronger and more flexible than that. Why? Give me a reason why you make it even stronger than you need to. Right? For example, I'll go back to my desk example. Right? Remember I said 250 and I said no, maybe 350? 350 is definitely going to be way stronger than a desk needs to be built. Nobody's going to put 350 pounds on a desk. Why do we make them stronger than we expect? Think about it. Give me a reason, just one reason. Second question, manufacturers, so builders, why are they interested in the things they build, their products, even after people have already bought them, right? So this desk again, I buy a desk. The manufacturer might ask me, hey, how's the desk holding up? Why do they care? Tell me why they would care how it holds up over a long time. A car manufacturer is another good one. Car manufacturers all the time are testing cars they've already sold. Why? Why do they care? It's already sold. Why are they interested? What reason might there be for that? This third one, so what you've got here, you've got a list of structures, and then a column that says environmental factor and best material properties. So in this column here, the environmental factor column, I want you to write either a type of weather or a type of temperature, hot, cold, whatever, that you have to consider when building a snowmobile. So I'll kind of give you the first one. Snowmobile, something you could write here is cold. You could write snow. You could write wet, right? Anything like that. For a motorboat, you're probably going to write, it's a boat, so take a guess. What's something in the environment that you might have to worry about? It could be a terrain feature too, like sand or water or um, winds, things like this. Okay? And here I want you to give me a material property. So something like resistant to cold, resistant to heat, resistant to water, flexible, strong, hard, um, high tensile strength. Like we went over a whole bunch of properties in the first lesson of this unit. I want you to write one of those. I don't want you to write a material. I want you to write a property. Okay? For each of these things that is important when you're building, say, a snowmobile. So snowmobile, you're probably talking about cold resistance or resistance to water. Those are both answers you could put here. All right, I want you to put one good material property that you'd have to consider for each of these things. Okay, so snowmobile, motorboat, house in a rainforest, windows in a hurricane zone, house in a desert, barn in a snowy area, and a tall building in an earthquake zone. All right? Okay, so that is your task for today. Once you are done that, you are good to go. And then next lesson, I will talk to you again. Take care of yourselves and stay safe until then.